This is the lesson for Chapter 11, Section 7, titled Graphing Rational Functions. And so let's take a look at our types of problems we're going to end up seeing. So first of all, we're going to have to deal with these directions. It says identify the asymptotes of the graph of each function, then graph the function. So we better figure out what these things are, these asymptotes. So a line is an asymptote of a graph if the graph gets closer to the line as x or y gets larger in absolute value. So let's take a look at our type of problem. First of all, a rational graph, a rational expression is one where we end up having x in the denominator of the expression here. So we see that we have an x value in the denominator and it makes a rational expression. And when we have x in the denominator, we can have excluded values. And so that's what makes these asymptotes. So for instance here, x cannot be 0. If x were 0, we would have an untrue statement. 1 divided by 0, we cannot have that. That's an error message. And so 0 is a number that is excluded. We also have y cannot be 0 either. And so we'll see that when we go ahead and graph this function, if we graphed it, it would have two separate graphs, and we would have these asymptotes. And the asymptote in this case is a vertical line along the it's just the y-axis, and we also have a horizontal line, which is the x-axis. Over here we see that we have a different asymptote. So we still have the x-axis as the horizontal asymptote. However, what we have now is an x equals positive 3. We can't have x at positive 3 because you notice how if you had 3 as x, 3 minus 3 makes 0. You can't have 0 in the denominator. So that's what makes that a solution that you cannot have. So what happens is the graph gets very close to that x equals 3, but just never touches it on either side, whether it be negative or positive values. So how do we identify these asymptotes? Well, we've seen on the x-axis what we can do is we can find that excluded value. You see, you find the number x cannot be. And so we just end up having to add 3 to both sides, and that's how we can get the vertical axis. And so this is the vertical asymptote. And so once we find the vertical asymptote, now we have to be able to find what the horizontal asymptote is. And so far it's always been the x-axis in this case. And so what we can do though is if we look at, we're going to see one of these problems on the homework where we have a term being added to the expression. And what we're going to end up seeing is that we've got horizontal asymptotes when y equals c, or the number being added to the expression. Here, the horizontal asymptote was 0 because we end up having no number being added to it. So you can add 0 to the value and not change its answer, and that's why the x-axis was the horizontal asymptote. So we're going to use those concepts. So again, our horizontal asymptote is right here when we have a number being added to the expression, or if we have no number added to it, then it is just 0. And so in this example here, you can see how we cannot have an x value of negative 4. And when we cancel this term out, we see that y is 1. And so we can't have a y value of 1 or x at negative 4. And so those are horizontal and vertical asymptotes. So that's what we're going to end up seeing on these lesson problems. So let's take a look at our first one here, similar to the one you're going to see. So first step is to figure out what the vertical and horizontal asymptotes are. So our vertical one is going to be where we set x equal to 0. Well, that was easy. X cannot be 0 in this case. So that's the vertical asymptote. Horizontal is the number being added to this. I see no number being added to it, so y is not going to end up being 0 either. So we're going to see the y-axis and the x-axis as the asymptotes. Now how do we figure out where those values go? Well, you can always plug in numbers, but I'm going to show you on the calculator how to come up with answers fairly quickly. So let's go to the mode section and press that and enter table number 3. And so it's going to ask for the function. And so we're going to enter the function that is right here where it says y equals 2 over x. We're going to press the fraction button right here. So we press that fraction button and we can enter 2 and then bring the cursor down and enter x. Now when we do that, we have to press alpha and then x. And so x is the close parenthesis right there, and that will enter it for us. And so now we're going to go ahead and press equals. and it asks us for the next function, but we have no other function, so then we're going to press 0. We're going to start somewhere. Now, when we start, let's go ahead and we know that x cannot be 0 and y cannot be 0, so we can start on the far left-hand side. So we're going to start at -5, so I'll go ahead and press in -5, and then we're going to end, and we can end at +5. Yeah, we can end at +5 there, and we're going to enter a step value of 1. Okay, so it's going to give us this table. Let's go ahead and copy down some of those numbers there. So I see that if I went ahead and I can scroll through there, and you can see how we can get all the x and y values. And then notice how right here we get a 0. When we have 0, we have error. And that's because, remember, our asymptotes are at 0. So we cannot have x as a 0 value. That's why it gave us that error message. So when we get that error message, it just means that that's not possible. It's not a possible solution. So we can continue scanning down, and you can see what those values are going to end up being. So I'll go ahead and write down what those values were. And so they are, I'll just go ahead and make a little chart here. And we have our x values and our y values. And so when we went ahead and plugged in -5, we ended up getting -4/10. When we had -4, we had a -5/10. And when we had -3, we had a -0.6 repeated. And when we had -2, we had -1. At -1, we had -2. And at 0, this was the error message. So that's our excluded value. So we're not going to end up using that number. And then we continue on. And at value 1, we had 2. At 2, we had 1. And then at 3, we had 0.6 repeated. At 4, we had 0.5. And at 5, we had 0.4. So we're going to go ahead and plot these. Again, we know what the horizontal asymptote is. And so it's going to be right along the x-axis here. And we know that the vertical asymptote is right along the y-axis. So that's something that you're going to want to fill in or really lightly kind of shade that in or dash that so you can kind of draw your graph and you know where it goes to. So we'll see it especially on ones where it's not on the axes. So over 5 spaces to the left, down 4/10 of a space. So really close. And then we continue on and graph these other points. And we've got another point about right here, and then one at -1, and then one at -2, and then it will end up getting really close over here. So we can see that this graph ends up doing this, where we end up getting really close to that x-axis, but just never quite get there. To get really close to the y-axis, but never quite get there. And so for this next one, we go over 1 and then up 2 spaces, over 2 up 1, over 3 up 0.6, and then so on. So you can see that we're getting ever so close to the y-axis and then ever so close to the x-axis, and that's what our graph ends up looking like. Let's take a look at the next one here. And on this one, we have a f of x this time. The function means the same thing as y equals 1 over x minus 2. And we want to find out what the horizontal and vertical asymptotes are. So our horizontal, we'll start off with, well, the horizontal, there's nothing being added here. So that means our horizontal asymptote, y, is not going to end up being 0. Our vertical, though, vertical asymptote, is going to end up being one where we set x, the denominator, equal to 0. So when I add 2 to both sides, I see that x cannot be positive 2. So I know that this line right here that goes, this vertical line that goes right through x at 2 is going to be my vertical asymptote. And what I do is I dash that line, and then I dash the line going for my horizontal asymptote as well. And so basically it's going to be the same graph, it's just going to be kind of shifted over, translated over. So for the first part, I'll go ahead and use the calculator now. Let's go ahead and clear this. And then we'll go ahead and plot these points here. So for this next one, we're going to go ahead and delete this function here, and we've got our function is a 1 on top, so we'll go ahead and go up there and cancel that out. And we'll enter 1, and then we'll enter the expression, so alpha x, and then we had a minus 2. And we'll go ahead and press equals. Now we know that if we look at where our expression is, we could start at -5, so that will work out there for us. And we're going to end up going to, instead of +5, let's go out, actually we can go out to maybe like a +7. Instead of starting at -5, we could have started a little bit further over. I'm going to end up just going out to +7 though in this case. And I could have started maybe like at -2 instead, since we moved our value over, and our step value will stick with +1, and we've got all these expressions here. And so you'll see that when we get down to +2, we're going to end up having that error message right there, and that's where our asymptote is. So I'm going to go ahead and write down some of these values that I ended up seeing. I'm going to start with -2 on the x value. And when we saw -2, we ended up seeing -0.25. At -1, I saw -0.3 repeated. At 0 is -0.5. And at 1, it was -1. And at 2, we saw that error message. And then at +3, we saw 1. And at 4, we ended up seeing 0.5. At 5, we ended up seeing 0.3 repeated. And 6 was 0.25. And then it got smaller from there. So we can go ahead and plot some of these points here. And so over 2 spaces to the left from the origin, just up or down a quarter of a space. And then we just get a little bit further down as we go. And at 0, it is halfway down. And at +1, we're 1 space down. And at 2, it was an error message. So what that tells me is it's going to get really close to that asymptote, the vertical asymptote, and really close to that horizontal asymptote. So it's the same graph as we saw before, it's just shifted over. So on this next one here, we're over over 1 space up over 3 spaces up 1 space, over 4 up just a half a space, and then it goes down from there. So I know what that general shape looks like. It's going to come up and get really close to that y-axis and really close to the x-axis, but just never quite touch them. Let's take a look at the last one here. And on this one, we'll have to re-enter our function. And we're going to change this function to, let's go ahead and go back there. And there we go. And we can press the fraction button to start with, and we'll enter a 4. And then we'll enter alpha x plus 2. And then the last part, we go ahead and scroll over. Make sure you press the arrow towards the right. And we need to enter a +1, so +1. And so now we press equals. And when we went ahead and figure out where our start values are, before we go ahead and figure those out, let's figure out what our horizontal and vertical asymptotes are. So our horizontal is the one where we have what y is. And so y is going to end up being 1. Our horizontal asymptote is 1. It is what the c value is. Our vertical asymptote is what our excluded values are. And so it's the x value there. So we set that equal to 0. The x plus 2 equal to 0. We see x cannot be -2. So that tells us that if we go over to the x-axis at -2, we're going to have a horizontal asymptote this way. And we're going to have a vertical asymptote of +1 right here. And if we go ahead and enter the values in there, we end up seeing that we'll start at -5 there. We'll go to +5 is fine on this one. And we'll end up getting our step value. And you can see that as we scroll down, when we get to our -2, there's our error message. And there we go from there. So we can go ahead and enter some of those values. And so we'll end up seeing that it's going to look exactly the same as what we had before. The difference is that we've just got it in a different spot. And so it's going to end up going really close to the towards the x-axis, but just 1 space above at y equals +1. Then it's going to come down and get really close to x at -2. And over here, it's going to do the same thing. So it's going to cross right there at that point, but then from there, it's going to get really close to the y value at y is at 1 and x at -2, and just never quite touch them. So it's, again, once you get those asymptotes, then it's really fast to graph that once you know that general shape. So those are the types of problems that you're going to end up seeing on today's lesson. Good luck.